Hello everyone and welcome to the second episode about my AWS Monster Chaos game. In the last episode, I showed a demo of the game. In this episode, I will show its infrastructure and explain how everything works together. Let's go right into it. This is the full architecture. It has 4 parts. An Adafruit PyPortal connected to AWS IoT and running a Minesweeper game. The AWS IT stack onto which the Adafruit PyPortal is connected. The Fault Injection service stack triggering the chaos experiment. And the web application stack into which we generate chaos. Let's start with the web application. It is a multi-tier application across 3 availability zones made of a load balancer layer, an Nginx reverse proxy, a web application service, and a DynamoDB NoSQL database backend. When a request to the page comes in, the load balancer distributes the traffic to one of the Nginx reverse proxy Fargate container. The Nginx proxy routes the traffic to the application service internal domain name. I use AWS Cloud Map here as a resource discovery service. It uses health check to maintain an up-to-date list of the available application containers for the internal domain name. The application container is running Node.js to query the score into the DynamoDB database backend and render the HTML page. The application container is running in isolated subnets and thus access other AWS services through VPC endpoints. This application architecture is overkilled, but it was designed to simulate a complex multi-tier application and provide multiple opportunities to generate chaos and break things. As mentioned in the demo, in the code I have released, the Nginx reverse proxy is on purpose misconfigured not to use the resolver. So the Nginx proxy is caching the IPs of the application containers. If they are stopped by a chaos experiment and new containers are provisioned with new IPs, the application will fail. This is done on purpose to simulate the case when the application is not surviving the chaos. You can change this in the Nginx configuration code here if you want, and redeploy using the CDK and stop the old tasks to provision the new one. The application should then be able to handle the chaos generated when all the web application tasks are terminated. That was the application. Let's now look at the opposite side, the Adafruit PyPortal. The Adafruit PyPortal runs a modified version of a Minesweeper game they developed, to which I added the code to connect to the AWS IoT. The IoT stack declares the device in IoT core and creates the certificate for the device, which have to be uploaded onto the device. When you lose a game on the device, it sends an MQTT message to AWS IoT. An IoT rule captures the message and triggers a step function in the fault injection stack. In the fault injection stack, the step function triggers a first Lambda function which randomly selects one of the fault injection templates. Currently, there are only 4 templates to remove one or all of either the Nginx or web application Fargate tasks. AWS has recently released new types of experiments which I plan to add later. The step function then loops until the experiment is either failed, completed, or stopped. At each loop, it runs a Lambda function which performs multiple calls to the application public URL. This is done to generate traffic during the Monster Chaos attack and to check if the application can handle the chaos or not. Custom CloudWatch alarms are set to count the number of failed HTTP requests at the Nginx level. This will be generated when the upstream app Fargate task go down, or at the load balancer level. These will be generated when the nginx forget tasks go down. The two alarms are aggregated into one. The fault injection experiments are configured to monitor the custom alarm. If the aggregate alarm is raised, it will stop the experiment. In this case, we lose the game as the application is not surviving the chaos, and the step function then updates the lost score in DynamoDB. If no alarm is raised, the experiment will stop after 5 minutes. In this case, the application can handle the chaos. We win the game, and the step function will update the won score in DynamoDB. So that's it for this demo. The code has been released on GitHub. You can find the link below. If you don't have an Adafruit PyPortal, you can still try it and just trigger the step function manually. I hope you will enjoy this chaos engineering game. Thank you for watching and see you next time.